Ataha
Yes, sir.
is the carbonyl compound aldehyde, ketones, and carboxylic acid. Is this chapter done in your school?
Yes, sir.
Okay, so you have some idea?
Yes, sir.
Okay, fine. So right now we are doing the, what are we doing? Yes, nucleophilic addition reactions of, in the chemical properties, we have done the methods of preparation, and physical properties. We are right now in the chemical properties, and in chemical properties, first now, right now we are doing the nucleophilic addition reaction. We have done a lot of them, and there are a few remaining. Just लिखिएगा, how much we are done. No. Three nucleophilic addition reactions are done. Fourth के लिए. This reaction is also there in alcohol, phenols, and ethers. So you may be remembering this. Please write with me. The fourth reaction here, you need to leave some pages or write in a rough sheet today, and then you can make the proper notes. Okay, Taha? A reaction with Grignard reagent. Now, in Grignard reagent, basically, we have a carbonyl compound. This may be an aldehyde or a ketone. C double bond O. We initially react this with RMgX, and in second step we add H2O. And what do we get here? This carbon atom, the two groups, they will be as it is. The double bond O become OH, and the R from Grignard reagent will attach to this carbon atom. Do you remember this reaction? Yes, Taha?
Yes.
So we can majorly divide this reaction into three different types. The first reaction is with formaldehyde, HCHO. In this case, the carbon it is bonded with oxygen with a double bond, and it has two hydrogen bonded to it. In the first step, we will have the same RMgX. In the second step, we will be having the H2O. Now, this carbon atom, it already has a few bonds. These are the two bonds with hydrogen. It had a double bond O that will become OH, and the R will be here. Or if you write it properly, it will seem like RCH2OH. R2OH, which is basically a 1-degree alcohol. Next, if we have any other aldehyde, I mean an aldehyde other than formaldehyde, we'll have RCHO with the same reagents. Now our carbon atom, it has two different groups attached to it. One is the alkyl group R dash, and another one is hydrogen. And we also have a double bond O, which will be converted to OH. And the Grignard reagents alkyl group will be attached on the carbon, which was carbonyl carbon. Now, if I write it properly, here we will be having R dash, then carbon, which is having one hydrogen, which is also connected with the alkyl group of Grignard reagent, and then OH. This is basically a 2-degree alcohol. And if we use a ketone, meaning if I have R C double bond O, and let us suppose R double dash, and we react this with the same reagents, we will have carbon. The two groups it already has is R dash and R double dash. The double bond O will become OH, and the Grignard reagent R will also attach on this carbon atom. Or we can write it like this: R double dash, carbon, R dash, R from the Grignard reagent, and OH, which is a 3-degree alcohol. Does this make sense? Yes or no, please tell me.
Yes.
हाँ जी बताएं. Copy this down. Raise your hand once you're done. Done? Great. Right, next. Reaction with alcohol. This is an important reaction. Generally इसको ना बच्चे भूल जाते हैं, ठीक है? So please always remember to revise this reaction. Reaction of carbonyl compound with alcohol. Reaction with alcohol. Now, in alcohol we have R, C double bond O, and H. I'm sorry, this is aldehyde. So first I am showing the reaction of aldehyde with alcohol, and I react this with R dash OH. The lone pair of oxygen atom will attack on the delta positive charge of carbonyl carbon. This carbonyl carbon, which is connected to more electronegative element, will be having delta positive charge, and this alcohol is going to attack on this carbonyl carbon like this. Now, as soon as it attacks, you can understand that this oxygen is trying to make a bond with carbon, but our carbon atom, it already has 4 bonds, so it will break the weakest bond, that is the pi bond, and we will get the next molecule, which is, so by the way, this particular reaction, it occurs in the presence of dry HCl. Dry HCl means in the absence of water. Now what we will get are carbon, single bond oxygen, hydrogen will be here, and here we will be attached with OR. The hydrogen of oxygen will migrate to this oxygen of carbonyl carbon, which was having a negative charge because of this shifting of pi bond. So here we will have OH. Now this carbon atom, it is again connected with 2 oxygen atoms, so this can also react with alcohol, and alcohol's oxygen can again react with OR dash, can again attack on this carbonyl carbon. Now once again, what is going to happen? This O R C H as it is, the OR dash is as it is. This oxygen atom, if it was having one alcohol, it got one hydrogen. From another alcohol, it will get another hydrogen, and it will leave as water. Can you see that leaving as water? Yes or no? Please tell me.
Yes, sir.
है ना? एक OH मिला, एक और हाइड्रोजन मिलेगा तो H2 निकल जाएगा, and then here also we are going to have OR dash. Now when our molecule is hydroxy alkoxy, that means there is one hydroxy group and one alkoxy group. Alkoxy group, this is known as hemiacetal. Hemiacetal. And when both the alkoxy group is present, then we call it acetal. Okay, write this down, and then you also need to write a statement. Topic, if you have not written, it is reactions with alcohol. You write with me. Aldehydes react with monohydric alcohol in the presence of dry HCl to form an important word, alkoxy alcohol. That means you will have an alkoxy group and a hydroxy group both, which is hemiacetal, which further reacts with one more alcohol to form gem dialkoxy. Gem dialkoxy का मतलब होता है geminal dialkoxy, which means a single carbon atom is having 2 alkoxy group. Gem का मतलब single carbon atom, dialkoxy उसी कार्बन पे 2 alkoxy group है. Gem dialkoxy compound. Dialkoxy compound, which is acetal. लिखिए बताएं अगर हो जाए तो. Assalamualaikum Mariam, how are you?
Assalamualaikum, sir. I'm fine. How are you?
You are not fine. Do you know that? हाँ Mariam,
Yes, sir.
you are not fine.
No, sir.
You are late. Why are you late?
I didn't see the time actually.
Wow. Oh my
नहीं मैं
God.
केमिस्ट्री पढ़ रही थी बट उस टाइम मैंने टाइम नहीं देखा.
Oh my God. ये तो मतलब ऐसा बिल्कुल बटर लगाने जैसा. केमिस्ट्री में हम इतने मशगूल हो गए सर आपके सब्जेक्ट में कि हमको टाइमिंग का पता नहीं चला. हाँ.
सर सच में एग्जाम आ रहा है ना इसलिए पढ़.
आपके सब्जेक्ट से ऐसे कोई नहीं है हमको सर. एग्जाम आ रहा है बस इसलिए पढ़ रहे हैं.
नहीं सर दोनों है दोनों.
ओह. लेकिन टाइम पे ख्याल रखें प्लीज, है ना. एग्जाम नजदीक
जी
आ रहा
सर.
है इसीलिए कह रहे हैं, है ना. आप इस रिएक्शन को अभी छोड़ दीजिए जरा, क्योंकि काफी चीजें यहाँ पे लिखी हुई हैं. आई विल गिव यू टाइम, यू कैन टेक स्क्रीनशॉट. कहा लेट मी नो वंस यू आर डन. इसका स्क्रीनशॉट ले लीजिए जब तक आप.
जी ठीक है.
कितने का ले लीजिए. कहा इज डन. यू आर डन टेकिंग द स्क्रीन.
यस सर यस सर.
उसके बाद ये टॉपिक एक छोटा सा है बस. यू वर प्रेजेंट इन द लास्ट लेक्चर राइट.
यस सर आई वाज देयर. ले लिया
ओके.
स्क्रीनशॉट सर.
ठीक. ना. when they react with monohydric alcohol, monohydric का मतलब होता है ना एक हाइड्रोक्सी ग्रुप वाला अल्कोहल. they form alkoxy alcohol which further reacts and it forms dialkoxy compound which is acetal basically. Now it can also react with dihydric, an alcohol which is having two OH groups. So let us suppose we have R, C double bond O and H. This is our aldehyde. Plus we have an alcohol. I am writing the alcohol. Just don't write now. Try to see CH2, CH2 and OH like this. So basically what is going to happen? Water molecule is going to be removed. Okay? And this oxygen will be bonded to carbon. This oxygen will also be bonded to carbon, which will lead to a product which will look something like this. Okay? Now these are the two new bonds which is being formed. As you can see, we have got a cyclic form. So this is cyclic acetal. What is this molecule? This is glycol, or specifically this is ethylene glycol. Now you can write aldehyde reacts with dihydric alcohol to form.
सर इस चैप्टर के बाद हम कौन सा चैप्टर करेंगे?
You tell me.
सर कोऑर्डिनेशन.
Okay. To form cyclic acetal, ketones can also show similar reaction, right? Keto, similar reaction to form ketal. We'll also see that reaction. Waiting for Mariam. How the reaction with ketones will happen? We have R, C double bond O, and R dash plus a very similar reaction in this also. Wahi water molecule is going to be removed, and we will get R is bonded to carbon, which is again bonded to another R dash, O, CH2, O, CH2, and there will be a bond like this. This is cyclic ketal. Acetals and ketals. Acetals and ketals can be hydrolyzed with aqueous mineral acid to form parent aldehyde or ketone. Parent aldehyde और ketone. क्या मतलब इसका? If I have acetal, उसमें आप पानी डालिए, तो जिस aldehyde से बना है, that aldehyde will be formed. And if you have a ketal, and if you add water, then whatever parent ketone was present in order for the preparation of that ketal will be formed. देखते हैं इसको. Hope you have written the previous reaction. For example, we have this acetal CH3, CH, OCH, and OCH3. Once you react this with mineral acid, that means in the presence of acid, you remove the alkoxy group. ये alkoxy हटा दीजिएगा, है ना? और सिंगल कार्बन पे ही लगा रहेगा. Fine, सिंगल कार्बन पे ही लगा रहेगा. So what will happen? When you remove this alkoxy, you will get CH3 and CH. इसी कार्बन पे डबल बॉन्ड O लगा दीजिए. And if you see closely, this is nothing but this is CH3CHO. Similarly, if you have something, let us suppose you have acetal. Acetal क्या है? CH3 CH. Here we have OCH3 और यहाँ पे आपके पास है OH. Once you add H plus in the presence of water, H और OCH3 हटा दीजिए. You will have CH3 and CH. जहां से आपने हटाया है दो बॉन्ड, वहीं पे डबल बॉन्ड O लगा दीजिए, and you get the same thing, CH3CHO. If you have something else, for example, you have something like this: OC2H5, OC2H5. Same reagent, water in the presence of acid. Remove the alkoxy. This is alkoxy, this is alkoxy. इसको हटा दीजिए. What will be remaining? You'll be remaining with something like this. The carbon from which you have removed the alkoxy, just add a double bond O there. That's it. And suppose you have something cyclic. है ना? So basically this is CH2 and this is CH2. तो ये alkoxy वाला पार्ट हटा दीजिए, ये पूरा पार्ट हटा दीजिए ना. This is alkoxy part. You remove this part, you'll be remaining with this much. Double bond O. This is basically acetone itself. Copy this down. Let me know if you understood this, yes or no. Sorry, Mariam and Taha.
Yes, sir.
Raise your hand, one student. Madhu, waiting for you. Okay. Right, Nick. Reactivity of aldehyde versus ketone towards nucleophilic addition reaction. ठीक है, चलिए जरा ध्यान से देखिए. Will come aldehyde and ketones, है ना? Aldehyde and ketone. Aldehyde में we have R, C double bond O, hydrogen. में we have R, C double bond O, and some another R dash. Okay. Two alkyl groups are present in ketone. There is only one alkyl. We have nucleophilic addition reaction. That means the reaction it is initiated by a nucleophile. Now, if the nucleophile is going to attack, it is obviously going to attack on a it is going to attack on a electrophilic center. Electrophilic center का मतलब जहाँ पे positive charge हो. So the oxygen atom here is having delta negative and carbon it is having delta positive. This oxygen is also having delta negative. This carbon is having delta positive. Now, the carbon's delta positive, it is somewhat decreased due to the presence of alkyl group. This alkyl group, it decreases the positive charge on carbon atom. If you look at ketone, it has two alkyl groups, and the decrease in ketone will be much more when compared to aldehyde, because here we have two electron donating groups, two alkyl groups. Here we only have one alkyl group. Hence, the positive charge in the ketone will be, much lower, less positive. This will be more positive. दोनों में डिक्रीज हुआ है, लेकिन ज्यादा डिक्रीज कीटोन में हुआ है ना. बोथ ऑफ देम देयर इज अ डिक्रीज इन द electrophilicity, but the electrophilicity of ketone has been much more decreased. That is why the attack on nucleophile will be easier. Does this make sense? Yes or no? Please tell me. ये पहली बात समझ में आई? हाँ या ना?
Yes, sir.
ठीक है. Another thing is, when the nucleophile is going to come and attack on this carbon atom, it will face only one alkyl group as a steric hindrance. But when this nucleophile will come to the ketonic, then it will face two bulky groups, the two alkyl groups, as steric hindrance. So if I talk about the steric hindrance also, it is easier to attack in aldehyde rather than ketone. Does this make sense? Please tell me.
Yes, sir.
Yes.
Right? So from this we can say that the reactivity of aldehyde is more than that of ketone. अब इसमें रीजंस क्या है? यहाँ पे तो रीजंस लिख देते हैं. नंबर 1 रीजन is less number of plus I group makes carbonyl carbon more electrophilic. Makes carbonyl carbon more electrophilic. In comparison, for ketones, more number of plus I groups makes carbonyl carbon less electrophilic. If I have not written, no, don't worry. I will give you time to write. Second point, steric hindrance is low due to one alkyl group. Therefore, reactivity is higher. Steric hindrance is high due to two alkyl groups. Therefore, reactivity is lower. Oh, let me know once you're done, guys. हो गया क्या दोनों का? Bariya
Yes,
and
sir,
Taha, let me know. हाँ लिख लिख आपसे एनसीईआरटी का क्वेश्चन कर लेते हैं इसके ऊपर। आई थिंक देयर इज अ क्वेश्चन इन एनसीईआरटी। Haloalkane, alcohol, aldehydes. Done. नहीं हुआ अभी।
हो गया sir.
Taha, what about you? Taha, okay, you're done. Taha. So, by the way, from here we can see that if I consider the steric hindrance and the electronic effect, both of them, then I can say that reactivity of reactivity to nucleophilic addition reaction, it is inversely proportional to number of bulky groups. Now, इसी basis पे we can answer this question. Here, this is, let us suppose A, this is B, this is C, and this is D. So we will make the structures and then we will decide. For the first question, we have A structure is ethanol. Ethanol is basically CH3, CHO. Then we have propanol, CH3, CH2, and CHO. Then we have propanone, 3 carbon atoms. Here we have double bond O. Butanone में 4 carbon atoms and we have double bond O. We know that aldehydes are more reactive when compared to ketones. So obviously, this is A, this is B, this is C, and तो यहाँ पे A AB will be more reactive than CD. अब A और B में कौन ज्यादा reactive होगा? Which is having less bulky group. So A is having less bulky group. So A will be most reactive, followed by B. C और D में कौन ज्यादा reactive होगा? If you compare C and D, then C is having less bulky group and D is having more bulky group. So there is C, and then the last will be D. Does this make sense? Yes or no? Please tell me.
Yes sir.
Now let us see this one: A, B, C, and D. First, second one, benzaldehyde. benzene ring with a CHO, A, P tolualdehyde. P tolualdehyde का मतलब क्या हुआ? CHO
पैरा पोजीशन
and
पे और
CH3.
CH3.
Very good. P nitrobenzaldehyde.
CHO और NO2.
Yep. Para position पे NO2. And we have acetophenone, which is benzene ring with C double bond O, and here we have CH3. So obviously the aldehydes will be more reactive in compared to this is B, C, and D. Aldehydes will be more reactive when compared to ketone. तो ketone को तो आखिरी में रख देते. अब इन देखिए, this is a plus M group, this is a minus M group, और यहाँ पे कोई भी ग्रुप नहीं है. So the plus M group, it is going to increase the electron density at the ortho and para position. तो पे delta negative charge आएगा. Now this delta negative charge is going to give electron density to the this carbon atom. CHO वाले carbon को electron देगा. Nitro group यहाँ पे क्या आएगा? delta आएगा, है ना? It produces a positive charge on ortho and para position. So this positive charge will take the electron density. यहाँ पे you can see that it is becoming more electrophilic. Can you see that? Yes or no, please tell me. The carbon पे और delta positive आ जाएगा ना, if it is pulling the electron density. Does this make sense? आ रही बात समझ में? हाँ या ना? नहीं आ रही है? Am I audible, guys? मरियम एंड ताहा.
Yes, sir.
हाँ, तो इसमें देखिए, between aldehydes and ketone, aldehyde will be more reactive. Now ABC में कौन ज्यादा reactive होगा? See, all of these are having benzene ring and benzene ring. तो बहुत ज्यादा यहाँ पे steric effect नहीं आएगा. Electronic effects will be much more prominent because the CH3 is a plus M group. It will increase the electron. यहाँ पे increase करेगा electron density and यहाँ पे will have decreased electron density. If there is an attack from nucleophile, I need a delta positive charge on carbonyl carbon. तो जहां पे ज्यादा पॉजिटिव होगा, that will be more reactive. So in this case, C will be more reactive. C will be most reactive. बाद you will have A, which is not having any plus M group, which is giving electron density, है ना? electron density देने वाला नहीं चाहिए हमको, लेने वाला चाहिए. A, that is 0, and after this we will be having D, and after that we will be having D, because it is a ketone. Let me know if you're done. Let me know if you're done, guys. Both of you are done. Very good. Actually, next type of reaction that we need to see is the reduction of aldehydes and ketones. Is right, the reduction of aldehydes and ketones. Now, there are two reductions of aldehydes and ketones. One is reduction to alcohols and then one is reduction to alkanes. So first one के लिए लिखिएगा reduction to alcohols. Reduction to alcohols. Now, these reactions we have already seen in the methods of preparation of alcohol. Basically, if we have carbonyl carbon, and if we have reagents such as if you have reagents such as lithium aluminium hydride. Oh, ये कार्बोनिल कंपाउंड हमने यार पूरा नहीं बनाया, एक से रुक जाइए जरा प्लीज. If I have C double bond O like this, and there are some groups attached here, lithium aluminum hydride, or if I have sodium boron hydride NaBH4, or if I have H2 in the presence of nickel, then I will always get this carbon atom, the two groups, whatever it was having, it will have those groups, and this will get a hydrogen. The oxygen will also get a hydrogen, and hence we are going to get a alcohol. The number of carbon atom remains same. So between the carbonyl carbons, aldehyde and ketones, we know that aldehydes gets reduced to 1 degree alcohol, and when we have ketones, gets reduced to 2 degree alcohol. इसके बारे में डिटेल में हम नहीं पढ़ेंगे because we have already seen the detail in alcohols, phenols and ethers. याद है कि नहीं याद है? Do you guys remember the reaction? नहीं याद है? Oh, yeah.
Yes, sir.
याद है थोड़ा बहुत ना? हाँ ठीक है. क्वेश्चंस देखेंगे तो आप लोग को समझ में आ जाए. Let me know once you're done. Waiting for Taha. Done. Great. Write the second, reduction to alkane. Reduction to alkanes में क्या होगा? The carbon will have two bonds like this and a double bond with oxygen. The two bonds will be as it is, nothing will happen to them. This double bond oxygen will be converted to H2. Reduction है. Now, there are two ways in which we can do this reduction. One is known as Clemmensen reduction and the other one is known as Wolff-Kishner reduction. Now, this goes without saying, whenever you see a name reaction, it is important, है ना? तो जब भी आपको नेम रिएक्शन दिखे, नेम रिएक्शन तो आना ही चाहिए. I mean, there is no other choice. You have to memorize the name reaction. आपको प्रैक्टिस कर करके, चैप्टर वाइज प्रैक्टिस कर करके नेम रिएक्शंस याद करने हैं. हाइड्रोअल्केन हैलोरीन के मेथड ऑफ प्रिपरेशन में स्वाट्स रिएक्शन, फिन रिएक्शन, इसी तरह से आप बढ़ते जाइए आगे. मेथड ऑफ प्रिपरेशन केमिकल प्रॉपर्टीज, मेथड ऑफ प्रिपरेशन केमिकल प्रॉपर्टीज, इस तरह से याद होंगे. Clemmensen reduction. And we have Wolff-Kishner reduction. Now, write A part, Clemmensen reduction. In this reaction, we treat carbonyl compounds with zinc amalgam. Zinc amalgam is a alloy. Amalgam में zinc डाल, sorry, mercury में zinc डाल दिया जाए तो उसको amalgam कहा जाता है. And it is basically a zinc amalgam. The zinc is added on mercury. Sodium amalgam, sodium added to mercury, and so on. In the presence of HCl, and we basically get carbon. The two bonds are as it is. The H2, C double bond से CH2 हो जाता है, plus we get a byproduct that is H2O. Now, इसमें ज्यादा आप लोगों को दिमाग लगाने की जरूरत नहीं है. If I have, for example, CH3 CHO and I react this with zinc amalgam ZnHg in the presence of HCl, then to count the number of carbon atom, उतने carbon atoms का आप क्या बना दीजिए? Alkane बना दीजिए. CH3 CHO, CH3 CH3. This is the alkane. Second, if I have, let's suppose, an acetone, C double bond O, and we use the same reagent, how many carbon atoms? 3 carbon atoms. 3 carbon atom का alkane बना दीजिए. That's it. Let's suppose if you have benzaldehyde. If you have not written, don't worry, I will give you time to write. I have benzaldehyde CHO like this, and we have zinc amalgam. Then CHO का CH3 बन जाएगा. Nothing else. है ना? O को हटा के 2 हाइड्रोजन ऐड कर देंगे. 1 हाइड्रोजन पहले से, 3 हाइड्रोजन हो गया. चलिए, copy this down. Raise your hand once you're done. Waiting for the. Great. If you want to write the statement, देखिए statement लिखना थोड़ा आना चाहिए आप लोग को once you have done the reaction, but इसके लिए लिखा देता for the next one you can write it on your own. When aldehydes and ketones are treated with zinc atom in the presence of HCl, it forms corresponding alkene. After this, write the B part, that is Wolff-Kishner reaction. Wolff-Kishner reaction or Wolff-Kishner reduction, है ना, एक ही चीज है. What happens here? We start with a carbonyl carbon. And we react this with hydrazine. अभी अगर आप लोगों ने हाइड्रोजीन नहीं देखा है, that means you have not in the previous classes. We have already done the reaction of carbonyl compounds with ammonia derivatives, और उसमें ammonia derivatives में we have hydrazine. I need a straight line. H2, NH2. This is hydrazine. इसमें क्या होगा? First of all, we will get a hydrazone in which we have carbon double bond N, which is further bonded with NH2. After this, we have to react this with KOH, and we need a very high boiling solvent. है ना? तो हम लोग we use ethylene glycol. We do not use water because we do not need 100 degree Celsius. We need more than 100 degree Celsius. ठीक है? तो हम लोग ethylene glycol use करते हैं उस केस में. It will become CH2. The two bonds will be as it is. There will be no change. देखिए प्रोडक्ट वही बनने वाला है जो हम लोगों का पुराना बना था प्रोडक्ट, है ना. फॉर एग्जांपल इफ आई हैव समथिंग लाइक दिस 1 2 3 4 कार्बन एटम CHO, and in the first step I have NH2, and in the second step I have KOH in the presence of heat. Count the number of carbon atoms, 1 2 3 4, चार कार्बन एटम बना दीजिए. For example, if I have something like this, a cyclic ketone and the same reagent, तो बस ये डबल बॉन्ड हटा दीजिए, 5 कार्बन एटम का साइक्लिक करेंगे, द रिंग विल बी एज दिस. डज दिस मेक सेंस? यस और नो, प्लीज टेल मी.
Yes, sir.
Copy this down, raise your hand once you're done. कहा आपको आ रहा है?
Yes, sir.
ओके. Waiting for the is also done. Next, we have some more reactions. लेकिन उससे पहले I will complete a short reaction, that is electrophilic aromatic substitution. Write the heading. This is generally the last reaction, but इसको complete कर लेते हैं because the other reactions are a bit larger. So electrophilic aromatic substitution. क्या होता है इसमें बताइए जरा. Guys have any idea? याद है थोड़ा सा कि नहीं याद है? Electrophilic aromatic substitution. What type of reactions happen in this? नहीं याद.
रेजोनेंस होता है ना.
रेजोनेंस होता है. रेजोनेंस तो होता है. दिस इज ब्रोमिनेशन, क्लोरीनेशन है ना, हैलोजनेशन, फ्री रेडिकल alkylation, free radical acylation, nitration, sulfonation. These are electrophilic aromatic substitution. याद कर लीजिएगा बिल्कुल. ठीक है. This will be in every chapter. सबसे पहली चीज यहाँ पे, when we do electrophilic aromatic substitution, where will the electrophile go? ऑर्थो पैरा पे जाएगा या मेटा पे जाएगा? So that depends on the active, that depends on the minus M or the plus M group. So please write aldehydes and ketones are minus M group and deactivating in nature. मतलब वो रिएक्टिविटी को भी कम करते हैं. और माइनस एम का मतलब क्या, क्या मतलब इसका देखिए. हेंस दे फॉर्म ओनली मेटा प्रोडक्ट एंड देयर reactivity is less than benzene. ठीक है. माइनस एम ग्रुप की वजह से मेटा प्रोडक्ट एंड डीएक्टिवेटिंग नेचर की वजह से इट इज गोइंग टू बी व्हाट, इट इज गोइंग टू बी लेस रिएक्टिव देन बेंजीन. इसको लिख लीजिए, देन आई विल शो द रिएक्शंस. Let me know once you're done, Taha. Okay, so first of all, we will do the reactions of benzaldehyde. Don't write now, आराम से देखिए पहले, उसके बाद लिखिएगा. Okay, so three reagents. First is Cl2 in the presence of FeCl3, and this would give me a chlorine as electrophile, and chlorine will attach on the meta position. है ना? This will attach on the meta position of this Cl. Now, if I use concentrated, that is conc HNO3 plus concentrated H2SO4, then in this case, we will get what happened by this will get NO2 group as the electrophile, and NO2 will be attached on the meta position like this. Last one is concentrated H2SO4. This will give us sulfonation, and in sulfonation we have SO3H group attached on the meta position, SO3H. Now, regarding the names of these molecules, so the name of this molecule will be, you can start drawing now. Got this? Yes or no, please, Amitaha?
Yes, sir.
This will be M-chloro. Benzaldehyde. This will be M-nitro. Benzaldehyde. Now, this is M-formyl. M-formyl. Benzene sulfonic acid. हम थोड़ा साइज कम कर देते हैं. ठीक है. This let me know once you're done. Very similar reactions is done by acetophenone also. A little bit of change, and you just need to copy the same things. So in acetophenone, we will be having C double bond O and CH3. Everything else will be same. If I draw it like this, does this make sense? Yes or no? बताएं जरा. Make sense? Yes or no?
Yes.
अब यहाँ फॉर्माइल नहीं है. We have M acetyl benzene sulfonic acid. कौन है मरियम? Let me know once you're done.